Hello everyone, welcome back. So we're now on to chapter 2, hardware. So in this chapter we're going to be covering the relationships among hardware device drivers, firmware, and platforms, common measurements used in computing, standard internal computer components, memory and storage, identifying different types of computers, keyboards, microphones, and touchscreens, typical smartphone hardware, Windows power plans, connecting peripheral devices, and wireless connection technologies. Device drivers. Software that allows your computer to communicate with and control the devices connected to it. Firmware, which is programmable logic embedded in a piece of hardware that controls how the device functions. And platform, which is the environment created by hardware and an operating system in which a program runs. A bit is the smallest unit of data a computer can understand. A bit can equal 0 or 1. 8 bits equals 1 byte. One alphanumeric character requires a byte of space. Measuring capacity. So this is what you typically see for your files and your hard drives or anything that stores information. So you start off with bit, which is a single binary digit. You have a byte, which is abbreviated by B, which is 8 bits. Then you have a kilobyte, which is 1024 bytes or 1000 bytes. Now, as we go down through this list, you'll notice that it'll all say 1024. And so basically the best and easiest way to kind of read this is it's 1000 bytes, 1000 kilobytes, megabytes, and so on and so forth. So we have kilobytes, which is KB, and that's 1024 bytes. So the 1024 is the exact measurement for 1 kilobyte. And the reason why we don't go and add in that 1024 is because it's a little more tedious to go and do so, and it's close enough to 1000. And you'll also maybe notice, if you pay attention to some of the specs, that some of the measurements that are allowed to go and give it a certain size may not actually be exact either. So do keep that in mind when you're reading about sizes, that it may not exactly be exact as what it's saying, but these numbers here are the exact measurement for each type. So we have a kilobyte, we have a megabyte, so that's 1000 kilobytes, a gigabyte, which is 1000 megabytes, we have a terabyte, which is 1000 gigabytes, and we have a petabyte, which is 1000 terabytes. Now obviously this should have been TB and not GB, so do keep that in mind. Now, measuring frequencies. So the lowest count is hertz, which is 1 cycle per second. And then, as you can see, we have kilohertz, megahertz, gigahertz, and terahertz, which all have their respective abbreviations just by adding in the first letter of each one and HZ. and each one goes up by a whole 1,000. So we start off with 1,000, then 1,000,000, and then 1,000,000,000, and then 1,000,000,000,000. Now, bandwidth, this is your measurement for your internet. We start off with bits per second, followed by kilobytes per second, or kilobits, and then megabits, which is 1,000,000 bits per second, and then gigabits, which is 1,000,000,000 bits per second. Now, the inside of your computer. So it has a system board, which is a printed circuit board that provides pathways for communication among all the components and connected devices. This is also known as a motherboard. So if you hear someone say system board or motherboard, know that they are the same thing. Now, sorry about that. So, kind of going back to processors. These are your CPUs, and they are silicone chips that control the hardware components and manages the flow of data instructions. Input devices. These allow you to send information to the computer. Output devices. These allow the computer to send information to you. And then there are storage devices. These include memory chips and other storage media. And lastly, we have power supplies, which converts AC current from a wall outlet into a low voltage DC power for the components. Memory and storage. Random access memory, also known as RAM, is used for the temporary storage of information, and it can store data only while the computer is running on. It's provided through the memory chips. Storage. Software programs and user files must be stored on the computer when they're not in use. Local storage is devices inside or directly attached to your computer. A remote storage is located in a location accessed over a network connection. Common storage devices also include hardware disks, flash drives, secure digital cards, also known as SD cards, and optical disks and drives. Now, optical disks and other drives may slowly be kind of going out. So there are other drives like your USB drives that will still be around, but as far as actual optical drives, those aren't very common anymore. You'll still see them in desktop replacement laptops, and you can still buy USB optical drives that can be connected via USB, but a lot of computers and laptops these days do not contain a optical drive. Computers come in a wide variety of forms and types, including servers, desktops, laptops, Chromebooks, tablets, and smartphones. Some types of computers are better suited to certain tasks than others. Servers support other computers. They run specialized operating systems and software for providing services. They are not used for personal computing and are used mainly by IT personnel. Desktop computers require peripheral devices such as monitors, keyboards, and mouse, are not portable, and are comfortable to use. Laptops, also known as notebooks, are self-contained, which means they require no peripherals. They are portable and can run on a battery power and include a rechargeable battery charged from an AC adapter. Chromebooks are specialized laptops designed to run cloud-based applications. They run the Chrome OS operating system, are lightweight, durable, and draw less power than their standard counterparts, and are less expensive, more durable, and way less than standard laptops. Now, obviously, the issue with this is that it only works with cloud-based applications, and there are more regular applications than there are cloud-based applications. Now, as we become more and more cloud-based, that will obviously change, but as of right now, there's still more regular applications than there are cloud-based applications. So if you're looking for a work computer, this is definitely not what you want. But if all you just want to do is roam the internet and do stuff online, then this is a very viable option. Now, tablets. These usually run on a mobile operating system. They feature a home screen, have a high resolution touch screen, and have good sound quality. They are designed primarily for entertainment purposes. Smartphones combine the features of a standard cell phone with those of a personal computer. They run a mobile operating system, can be used for a variety of tasks, allow you to install, configure, and run numerous apps, and come complete with a touch screen, software, cameras, memory, support for removable storage, and support for Wi-Fi connections. Now here is a standard keyboard for Windows, and you know it's a Windows keyboard because of the Windows key. So you have your escape, you have Control, Alt, the Windows key, your function keys, cursor movements, and numeric pad. And this type of keyboard is also known as a full-size keyboard because of the fact that it has a numeric keypad on it. Now here's your standard smartphone. It has proximity and light sensors, a status light, earpiece, front camera, volume keys, a power lock key, a back button, a recent apps button, a home or finger scanner key, a microphone, an infrared transmitter, rear camera, flash. It could have a heart rate sensor, a SIM tray, speaker, microphone, headset jack, and USB charger or accessory port. Now, smartphones use virtual on-screen keyboards and dial pads. These are presented in a series of screens, and on here we have examples of the dial pad and the keyboard that is used. Power plans. So power plans primarily affect the battery life in laptops. Use them on your desktop system to conserve energy and take a greener approach to computing. Connecting peripherals. The peripheral device attached to the PC through special sockets called ports, and there are multiple ports. So we have video port, which allows you to connect monitors, projectors, and TVs to display the output. Network ports, which allow your computer to connect to a network. Audio ports, also called jacks, deliver sound from the sound card to the external speakers or headphones. And a USB serial bus, also known as USB ports, which allow you to attach a wide variety of devices and can also supply power. Now, talking about displays, you can go and utilize some of these options when you are using one or more displays. So duplicate these displays shows the same output on both monitors. Extend these displays shows different output on each monitor. Show only on one shows output only on monitor 1. Monitor 2 goes blank. Show only on 2 shows output only on the monitor 2, and monitor 1 goes blank. And here we have an example of a USB and its USB ports. So they are used to connect mass storage devices, connect human interface devices, and can deliver power. Printers. Printers connect to PCs using USB or network connections. And when you plug into the cable, Windows detects the printer. Now here's kind of a fun little fact about printers, and this was before USBs were prevalent. They used to actually have their own printer port that you would connect the printer to in order to be able to print on that printer. But since USBs have gotten better and better, they've been able to move away from needing to provide that port, and we're able to go and now run printers on USB. So to connect wireless peripherals, you can use Bluetooth and infrared. So, lesson summary. The relationship among hardware devices, drivers, firmware, and platforms. We've covered common measurements used in computing. We've covered standard internal computer components, memory and storage, identifying different types of computers, keyboards, microphones, and touchscreens, typical smartphone hardware, the Windows power plan, connecting peripheral devices, and wireless connection technologies. Now, in our next class section, we will be working on learning how to convert the measurements, primarily the storage measurements, and also playing around with the monitor for showing on one, both, or extending or showing just a copy of the main desktop, since we have dual monitors in the lab. So please make sure you're reading through the chapter as well as going over the lecture slides. And if you have any questions, please make sure to have them ready for our next lesson, and I'll do my best to go over those questions with you. Thank you very much, and I look forward to seeing you guys next time.